Welcome. So in this video I'm going to derive the quadratic formula, and when we say derive, what we mean is we're going to show, or in this case I'm going to show, how the formula was developed, where it came from, how it was invented, how it was discovered, however you want to characterize that. It came from somewhere, and I'm going to show you how that happened. So it's going to be good for you to follow along, jot some things down as you go, and by the time we're done, you'll have an idea of where this thing came from. And then we'll follow up with what in the world do you do once you have the formula? How does it help us solve quadratic equations? So let's dive into the deriving part first. So before we begin, let's just consider our quadratic equation. This equation's in what we usually call a standard form. It's ax squared plus bx plus c. The a, b, and c, which are written in blue, these are all coefficients, right? So those are just numbers in front of x squared, x, and then by itself. And I put them in blue because we're going to need to identify those numbers later while we're using the quadratic formula. For now, this is the equation we're going to work with. We won't have numbers there, they're just letters, because we have to find out where this quadratic formula that I've been talking about came from. So we're thinking about this equation ax squared plus bx plus c, and we're going to use a technique called, completing the square. We're going to complete the square to derive the quadratic formula. If you're not familiar with completing the square, you can still follow along with the video, that's okay, but I will use that technique along the way. So let's dive right in. For starters, the problems that we've been working on, the quadratic functions that we've been factoring or the quadratic equations that we've been solving, are usually easier when there's just a 1 in front of the x squared. In other words, when there's not really a coefficient there. So what I'm going to start with is I'm going to divide everything by a to turn that coefficient into a 1. Okay, and everybody's done this before. We're just using inverse operations. As long as we divide everything on both sides of the equation, we're allowed to do that. And you'll notice what happens is that this turns into a 1, and I end up with a new equation. That equation is x squared plus b over a. I have no idea what that is, so I'm just going to write the fraction b over a times x plus some fraction c over a. I have no idea what that is. And then 0 divided by a. I can do that math, thank goodness, so that equals 0. So step 1, we just divide everything by a. Now what we're shooting for is a perfect square trinomial, and right now I don't know for sure if I have that. So this c over a I need to remove from the situation. I'm going to put something else in its place. So the way we remove it is we subtract it from both sides. And again, it's just an inverse operation. We are allowed to do that. And as you know, when you do that, these cross out, right? And we're left with x squared plus still b over a. We haven't messed with that yet. B over a times x. And then there's nothing in this position right now because we got rid of it, but I'm going to leave a little gap there. And on the other side here, 0 minus c over a. I have no idea what it is, but I know I can write it. It's negative c over a, or the opposite of c over a. Okay, so right now we have this quadratic equation. You can see I've got a little gap there between the x and the equal sign, because what we need to do is we need to insert something in there. And in order to complete the square, what I'm going to do is take half of the coefficient in front of x and then square it. That's how we know we have a perfect square trinomial. So bear with me here. I'm going to do this in well, 2 steps. Let's just talk about this on the side here. If you want to do half of something, what you do is you multiply it by a half. So I'm going to multiply b over a by 1/2, and that equals b over 2a. And then when you square that, you square all of the factors. And so what's going to happen is I want to end up with a plus b squared over 4a squared right here. I'm not allowed to do that just on one side. I have to do it on both sides. So this is plus b squared over 4a squared on this side as well. So now that we have that, let me just show you the important pieces that we have now. I mucked this up a little bit, but this little statement here in the green oval, this is where we're currently at, and that's where I'll pick up on the next screen. But we have x squared plus b over ax plus b squared over 4a squared equals whatever this negative c over a plus b squared over 4a squared is. So I'm going to start on a blank screen. We'll clean that up and we'll see if we can work with it. And it turns out we can. Okay, so we have this quadratic equation. It's x squared plus b over ax plus b squared over 4a squared equals, and then on the right hand side I did flip these things around. We had negative c over a plus b squared minus 4a squared. We typically write this as a subtraction. Excuse me. So I made it b squared over 4a squared minus c over a. Okay, now we've been factoring quadratics, and so you may or may not recognize the fact that right here we have a perfect square trinomial. The front end is x times x, and the back end is b over 2a times b over 2a. And so the way that factors is x plus b over 2a, and the whole thing is squared. And on the right hand side, we have these two fractions that we want to subtract. And for now, I'm just going to leave those as b squared over 4a squared minus c over a. And eventually I'm going to get a common denominator and clean that up. But the cool thing is, we know that if you have something squared and you want to solve to find out what that something is, we use square roots. So that's going to be our approach. In order to solve this equation, we're going to need to use square roots. Before we do that, I think it probably is a good idea that I take these two fractions over here and I subtract them using a common denominator. So the way we do the common denominator is we just see what they have in common. And so on the left hand side we've got 4 times a, or 4a squared. On the right we just have an a. So what we really need to do is multiply both of these by 4a, and that'll give us our common denominator. You can only multiply the top and the bottom to keep it the same. You can't just multiply the bottom. So what we end up with before we move to the last screen here is we end up with this perfect square trinomial. Oops, I really wanted to make that black. This perfect square trinomial, when we factored it, it was x plus b over 2a, and the whole thing was squared. And on this side, with our common denominator, we end up with b squared, and 4a times c is just 4ac, and on the bottom the common denominator is 4a squared. So this is where we've ended up. I guess I switched to black ink, but you see where we're at here. I'll start here on the next screen, which is where we're going to use our square roots. Okay, so let's see if we can finish this thing off. So on the last screen we ended with the quantity x plus b over 2a squared equals b squared minus 4ac over 4a squared. And what I mentioned was if we want to solve for the thing in the parentheses, in this case it's x plus b over 2a, right? That's the quantity that's squared. We use radical signs to solve for that. And remember, we don't know if it's going to be the positive square root or the negative square root. So we've got to take the square root of the whole doggone thing. B squared minus 4ac over 4a squared. And then we're square rooting the whole thing. Now, we've learned that when you're taking the square root of a fraction, you can square root the individual pieces, or the numerator and the denominator. And it turns out this denominator we can take the square root of. We know the square root of 4 and we know the square root of a squared. We can't take the square root of this difference here, b squared minus 4ac. That's not going to work out. That's not a perfect square. So what we end up with is x plus b over 2a. I guess I switched to all black here. And in the numerator, we end up with the square root of b squared minus 4ac. But in the denominator, we have 2a, because that's the square root of 4a squared. And that's good news because I'm about to solve for x over here. And the fraction that I'm using on this side also has 2a in the denominator. In fact, let's do that right now. Let's subtract b minus 2a from both sides, b over 2a. These will cancel out. I'm going to end up with x equals, but you can see that I've run out of space on this screen. So on the last slide here, I know I said this was the last slide, but now I'm going to add another one. On the next slide, we will have arrived at the quadratic formula, and I'll put it in a box and we'll have a party because we've achieved the quadratic formula. So as I said, we need to subtract b over 2a from both sides. And the cool thing is, when you do that, you end up with two expressions for x. Since these are common denominators, we can write the whole thing as follows. The opposite of b, plus sign and or minus sign, the square root of b squared minus 4ac. Oops, that's a terrible looking c there. Let's see if we can fix that. Over that common denominator 2a. And as I said on the last slide, we're going to put that in a big huge box because this is the quadratic formula. And the algebra involved is a little crazy, I agree, but this is definitely worth a smiley face. What we did is we started with a generic or standard quadratic equation, quadratic trinomial set equal to 0. We used inverse operations and a little technique called completing the square so that we could find a perfect square trinomial that we could factor. We factored it, and then we solved for x by taking the square root and then using another inverse operation. Now, do you have to be an expert at that to use the quadratic formula? The answer is absolutely not. But I wanted you to be able to see where the formula came from, how it was derived originally, and understand that these things don't just get pulled out of the air, that somebody sits down and thinks about them and runs through a bunch of calculations in algebra to achieve them. We are lucky enough to be able to take advantage of what people have found and use it to solve quadratic equations, which is what we'll do next. So thanks for listening, and good luck solving quadratic equations using the quadratic formula.